Now that you've been introduced to how to draw Bohr-Rutherford diagrams that show not only an atom's nucleus, but also all of the electron shells, it's time to learn how to draw a simplified form of these structures, which are what we call Lewis structures. And when we say simplified, we really mean simplified, in that we're only taking two details from a Bohr-Rutherford diagram, the first of which being the chemical symbol. So if we take a look at this atom here, we can identify which element it is simply by looking at the number of protons. In this case, it is 9. And if we look for element number 9 on the periodic table, we can see that that element is fluorine, and so we write the chemical symbol F right here. Now, for those of you that wanted to point out, but you named fluorine right here, that's true, I did, but the exercise previously was just to show that even if you weren't given the name of the element, all that you need to do is look up the number of protons, because that is the atomic number, and that helps us find the chemical symbol. Finally, if we remember what valence electrons are, which of course are the electrons in the outermost shell of electrons, that being the shell that is farthest away from the nucleus, so let's keep that in writing here, we can simply use the Bohr-Rutherford diagram in order to count how many electrons there are in the valence shell. So 2, 4, 6, 7. So here we can see that fluorine has 7 valence electrons, and therefore we can add the 7 valence electrons into fluorine's Lewis structure, and at this point we are done. This is why we say that Lewis structures are significantly simpler than Bohr-Rutherford structures, because as long as we know what the atom is represented as in the Bohr-Rutherford diagram, it's simply a matter of taking the chemical symbol and the valence electrons and using that to construct the Lewis structure. If you want additional practice, we can try these two examples here. So we're going to first look up what each of these elements' symbols are based on their number of protons, 17 and 14 respectively. So we can see that chlorine is the one that has 17 protons, and silicon is the one that has 14 protons, so we can go ahead and write the chemical symbols for each of the elements here. Now, because I've saved time for the purpose of this video and already drawn the Bohr-Rutherford diagram, all we need to do is look at each of the elements' valence shells and count electrons. So chlorine has 2, 4, 6, 7, just like fluorine, so we can go ahead and put those 7 electrons for chlorine's valence shell, and silicon is actually more similar to carbon in that both elements only have 1, 2, 3, 4 electrons in their valence shell, all of which are unpaired. Now again, normally, in order to figure out the Lewis structure, we would need to draw the whole Bohr-Rutherford structure just to see how many valence electrons the element has, unless we knew of a shortcut. So here we can see the Lewis structures for all of the elements, except for the ones in the middle of the periodic table, the transition metals. We can see that all of these elements' Lewis structures are drawn according to their group. So this group here, lithium, sodium, potassium, rubidium, and cesium, on the periodic table is labeled group Roman numeral 1A. And if you aren't sure what we mean, we're talking about this group identification number here. Now, as we can see, this group is called 1A, and every single one of the elements in group 1A has 1 valence electron. Then the next group over is group 2A, and we can see that every single one of these elements, beryllium, magnesium, calcium, strontium, etc., all have 2 valence electrons. So it shouldn't come as much as of a surprise that all of the elements in boron's group, group 3A, have 3 valence electrons, and so on. So this is the shortcut that we can use so that we can actually draw Lewis structures for a specific element as long as we know what group it is in, because the group number determines the number of valence electrons that an element has, and as long as every element is in the same group, all of those elements will have the same number of valence electrons, which is what makes it easy to predict how many valence electrons a given element will have. Now that you've learned how to draw both Bohr-Rutherford and Lewis structures, you can take a look at the practice problems below. First, if you need a review for how to use the periodic table in order to determine the number of protons, neutrons, and electrons, you can take a look at these first practice problems here before taking a look at the practice problems here, where in the rings of concentric circles, you're given space to draw the Bohr-Rutherford diagram, and in the box, you're given space to draw the Lewis diagram once you figure out the number of valence electrons that you have. Although, as we now know from the shortcut, you can simply look up the group number to find the number of valence electrons either way. So once you've tried those practice problems, in the next series of videos, we're going to be taking a look at what happens to the valence shell when we make sure that it has a full amount of electrons within it.